In his latest video, Dave Farley from the Continuous Delivery channel informed us about Cynefin as a game changer, and he identified software development as a discipline to be in the complex domain, not in the complicated. And I tend to disagree on this one. I think it's more nuanced, and I'm going to explain this to you in my video here, and I'm also going to point out in the end, like, how does this relate to modern AI systems, and why does it matter? Welcome to Frankly Developing. I'm your host Frank, and today, before we dive deeper, let me talk about Dave Farley first. Because it's not so much that I disagree with him totally, on the contrary. He's doing really great work, and he's an author, he has the Continuous Delivery channel on YouTube here, and I absolutely love his work. I read his book and I can recommend it wholeheartedly, just like you should subscribe to his channel. I would prefer if you subscribe to my channel as well, but I guess it makes sense to subscribe to his. He's doing really good work. And again, this is not so much a disagreement as more of a nuanced kind of thing. So before we dive into it, we have to quickly recap the Cynefin model. Dave Farley made a video, obviously. You could look at that one. I also made a video. I'm going to link it to you up there. So we're just going to do a quick recap here. In the Cynefin model, we have these 4 quadrants of problem spaces. One that is simple or clear, has been renamed now, which is the area of best practices, where everything is fully understood. And then it gets more complicated when you need to bring in experts to do analysis, and the cause and effect relation is really hard to understand, but it is understandable. And you can also do something like look into the future and come up with a plan, basically, based on understanding these complex cause and effect chains. And then there's this complex domain, where these cause and effect relations, they exist, but they are not repeatable in the future, and they are not really analyzable in advance. So you can look at them in hindsight, which is why in software, of course, if you look at it as a complex system, when we look back, we know better on what we did wrong, why it went wrong. But it doesn't help us moving forward in a complex system. And then there's this chaotic part, which of course is something you just want to get out of by acting and seeing where it takes you. There's no relationship between cause and effect, and as that, there's no point in planning or thinking and analyzing anything. You just act, you just do something in the hopes of getting out of that. In the middle, there's this theoretical fifth thing that basically just means you don't know where you are. But of course, you could play software in there. Now, the point about this video is, of course, is software development a complex, a complicated, or something else area of problems that we solve here? Where Dave Farley says it's clearly not complicated. I have this in a more nuanced understanding, in my head at least, where in general I agree with him that it is a complex endeavor, but there are a lot of aspects, and I'm going to give you 2 really big lines of reasonings on why software development or aspects of it can quite well be in the complicated domain, sometimes maybe even in a simple domain. When you work on a software project in a regulated industry, you have to follow some norms, particularly around functional safety. When the life of people is at stakes, you can't just do whatever you want. You have to follow strict guidelines and processes. For example, there's the DL178 if you want to develop something for an avionics system. There's the ISO 26262 in the automotive area. There's IEC 60880 for the nuclear power plants, or ECSS EST4C if you want to go to space. So all of these kind of restrict you. How does that relate now to Cynefin? By the process of these standards that you follow them, they take out some of the creativity of the work that other industries apply towards software development. They enforce a certain process. So you may be in the position of having to design something, but you're not allowed to discuss or change the requirements anymore or the architecture. Those are already in there and in place, and they are in someone else's responsibility. And there's a certain process. You can't just change things like you want, and you have to go through a change management board and things like that. So specifically, you set up the project by creating complicated sub-problems. So you move the landscape of the Cynefin model from an overall complex thing into smaller things that are complicated on their own and done by experts. Some may even go down to be a clear thing. So for example, if you have architecture and design already in place, it limits the complexity of what you can implement under all of these constraints. So it's not that creative act really anymore, and it's really just a lot of doing. It may be complicated still, and you may need experts, of course, but there's not that much flexibility left to go into this complex domain. If you, for example, have all the code and the requirements in place, but you have to just write the unit tests, you're in a pretty much clear domain territory. It's rather straightforward. So straightforward even that we have tools that can do it for us. And if you look at the time that the developers spend actually working on code in their IDEs, if you work outside of these regulated industries, usually you hear things like about 30% work on new features, but even altogether with testing and maintaining, you're well over 70% of your time working as a developer on the code itself. This is not the case in a regulated industry when you do functional safety, for example. In these areas, it's really hard to find a lot of public data, but I have a lot of colleagues that write this kind of software, and from my experience and interacting and discussing with them, the overall time a project is spending on writing code is maybe at most something like 10% only, which begs the question like, are we still that interested even if complex or complicated is the answer to where software development in this kind of thing lies? Because the kind of work we are thinking of there is limited to a very tiny aspect of the whole project. So is Dave Farley wrong then? Well, not entirely. As I said, it's more nuanced. There are areas where a software engineer has to do complicated or even clear work. It's likely not what software development looks like for most of us, and it shouldn't. If you're not in a regulated industry like that, why ever would you want to be this inefficient and spend so much money on code? But if you are, I think the entire problem landscape changes. You can also see this in the approaches being taken. For complex problem domains, like Dave Farley explained so well in his video, you want to experiment a lot. And if you contrast that with almost all of the critical avionics software still being written in C, well, experimentation and throwing away a few bad experiments, it's not something you want to do if the experiments cost hundreds of millions of dollars. But by spending that amount of money on changing the landscape, the problem landscape itself, you can at least get a lot more reliability and planability in return. I promised a second reasoning line, and that is that granularity matters. While I agree with Dave Farley on the big picture, there is something to be said about the tiny details. Sometimes we have situations in which you just have to do some coding work, boring stuff, clear work, but it needs to be done. As I promised, this is where all of this relates to modern LLMs. We can use AI to completely get rid of the work that is clear. When we as experts supervise its work, we can also use it to tackle complicated problems, a lot of complicated problems. But when it gets to complex challenges, there's experimentation needed. Currently, we can get some limited support from an AI in designing, executing, and analyzing experiments. But my personal take on LLMs in particular is that their very foundation makes them unsuitable for complex domains. They try to anticipate the most likely future based on historical data they have learned. But by the very definition of Cynefin's complex domain, the past cause and effect relation isn't repeatable in the future. I hope you now understand why I disagree with Dave Farley and at the same time totally agree with him as well. It's all about which point of view you take. And consider this Cynefin model when you are subject to the current AI hype, and check out what kind of problem space it is really solving for you. As always, thank you for watching and have fun developing.